So here we have a custom guitar amplifier. It is the 100. This is one of those tuck and roll style. I looked up the serial number, and according to the serial number in some chart I found online, this was made in the summer of '69. I came across this amp doing electrical work in a garage. I noticed it tucked away behind some boxes, and I asked the client if they were interested in selling it, and they weren't interested in selling it, but they were alright if I borrowed it. So then I borrowed it, and I was running a line into it to process a snare to go through the head and make use of the reverb that's on here. It has spring reverb. It's a very big, lush spring reverb, and it just sizzled, and then no sound was passing through. It was still on, but and the reverb would make its noise, but the input was not getting to the output, the speakers. So I took it to several guitar repair shops close to me, and none of them were able to repair this amp. So I held on to it for another year or so until when I was in the process of moving, I decided, or mustered up the nerve, to take the amp back to the owner and let them know that it had broken while in my possession, and I tried to get it repaired, and nobody could fix it. And he didn't get upset. He was very cool about it. And I acquired this in 2006, and I returned it to him in, I believe, 2011. And we're currently in 2024, and I contacted this person again, and I asked if it would be possible if I could take the amp back and try to fix it myself, because in the later years, I accumulated a good bit of troubleshooting experience with electronics, and I think it's worth a shot to maybe try fixing it. And he said, all right, and he gave it to me, and I took it on, and within a day, I found all the issues and resolved it and got it back up and running. So I'll just kind of talk about some of that work. We'll take a look here at the back of the unit. We got the back of the head and the back of the speaker cabinet, and here's where you plug your speaker cable into. So I believe these are the Jensen speakers, and then up top here, I believe that's the original cord, nice and long. Here's the power switch. Middle is off. Left or right or left would be on. Here's a little bit of that stuff saying input 0.9 amps. Okay. Here's the identification here. The model number is K102, and it's stamped in there, but I'm not picking it up on the camera. Let's see if I get close enough. 44389. And according to a chart I found online, yeah, so 443 would fall into July to September 1969. The face of the head has a very reflective plexiglass or something. So I think what I want to do is just open it up and just kind of show the things that I found wrong with it and the corrections I made. So in order to get the guts out, you have to flip it upside down. There's 4 screws on the bottom. They are Phillips heads, and they have washers. Okay, so I've pulled the head out of its enclosure, and just sort of a general little scan of its structure here. As you can see, there's 1, 2, 3, 4 of these bars that go across, and the 2 middle bars have screws going through them that actually screw into the reverb tank. We could see that there's a little bit of cracking over here, but it's got a foam cover on it. Okay, so pull that back, and oh yeah. Ooh. Okay, so you have these 2 springs in here, and they're in a tank, and that tank is elevated by springs on the side of it, so it's sort of floating. Oh yeah. Well, close that back up. Alright, so before I go any further, this is the original speaker cable. It's a Switchcraft, and it had issues where I was having intermittent connection between the tips and the ground. It was failing to have good secure continuity. If you jiggled the cord, it would kind of cut in and out. I have a replacement speaker cable here, actual speaker cable, made in USA, 16 gauge. Alright, but I guess next I'm going to remove the flathead screws to take this reverb tank out. There's a ground connection there that I have to take that screw out. And then the reverb tank itself has RCA connections going into it, like an input, I believe, and an output. I need to disconnect those, and then once I do all that, I can remove this whole tank and we can see the inside a little bit better. Real quick, this reverb tank, now that I've removed it, the one repair I've made was that the wire going to its little terminal, or its little connector here, was ripped out. So I did my best and used my big soldering gun to heat that up and solder that back on. I'll put this to the side now. So taking a look on the inside here, it looks pretty empty because all the actions, the PCB is on the front panel here. I want to disconnect these RCA wires. Put those to the side. But before I flip it around and get a better view of the PCB side, we'll take a look at this backside business. We have the power transformer, this little circular black round thing in front of the power transformer is the bridge rectifier, where internally has the diodes where it converts the AC that's been knocked down by the transformer and converts it over to a DC voltage. We've got our power supply caps here, the filter caps. These are nice. They have these screw terminals, and you can just unscrew the screws and take the wire connections off. So I was able to test them. And when I tested those, I just saw my notes. They're rated at 2,500 microfarads, and the one read 3,104 microfarads, and the other one was 3,459 microfarads. Both had 0 ohms for their ESR, and both had voltage loss of 1%. I took that as those caps work fine. We have the switch for the AC line. Down there is the speaker jack for the speaker cable. Here we have a fuse. Inside of it was, I believe, I have it over here. The fuse that was inside of it was, it was blown, but it was rated at 0.3 amps, so 300 milliamps, and it was cooked. So what I put in there in replace of it was a 1 amp fuse, and I believe it's a fast blow. And I guess that kind of covers everything we see there. Overhead, you can see, since you have your power transistors right here and right here, this is a heat sink, and if this gets too hot, I believe this thing will open up and cut power to the unit so you don't cook your power transistors if they're too hot. Okay, so here we have the PCB. It's one large PCB, and everything is mounted to that and pops through to the front side, your potentiometer knobs and your indicator lamp. The board, pretty interesting. The only electrolytic capacitors in this entire thing are the filter caps for the power supply, these big ones here. The board itself didn't have any electrolytic caps. And normally when I would troubleshoot a circuit, I would look for electrolytics and see if any of them were swollen or had leaked out. and this circuit didn't have any of those to be found. So pretty interesting with the circuit design. I think that gives this the circuit board a lot more longevity, because of these types of caps seem like they're the kind of caps that don't fail or dry up, or have the reputation for doing so like electrolytics would do. The jacks are, the one up here is for the foot switch, and then we have the two input jacks, and they're all switchcraft. There was a wire, let's see if we can get a good sight of it. This little wire down here makes a jump. It's acting as a jumper on the PCB. The original, that's a replacement wire. The original was hanging out one end. I remember that when I opened it up back in 2007, I think is when it actually failed. And I couldn't see where it connected, and I thought maybe that's an issue, but I didn't know what it was or what it was doing. But it was still hanging, and when I removed the whole PCB, the wire fell out from the other side, and I was able to see the 2 points where it was supposed to be soldered in. So I replaced that with adequately gauged wire. I actually have the original wire. There's the original wire. It was a solid strand, and I used stranded. That's what I had on hand, but yeah, that was just dangling. So I figured, hey, replace that. That's step one. That's easy enough. And the fuse, knowing I could replace that, but the reason the fuse blew, I needed to figure that out, because I probably would just blow the fuse again if I turned it back on. I doubted that wire being disconnected would have caused it to blow the fuse. And the lamp was easy enough. I had to order those. So trying to figure out what else could be going on. There was no burnt up parts on the back side here. And so I figured the next step would be taking a look at the transistors, the power transistors. Okay, so here are our power transistors. They're both the same 36892 RCA. 36892 RCA. They have 76 on them. I thought maybe that meant they were from 1976, but the serial number for the amp says 1969, so I don't know. Now, when I was diving into this repair, I was taking lots of pictures. I was taking notes as I went along. And one thing that stood out to me when I was taking pictures of these two, where I noticed that one of these, I can't remember which one, but one of these power transistors was missing the mica insulator underneath of it, and the other one had it. And I thought, well, I don't remember taking that stuff apart. Back then, in 2007, my troubleshooting skills were about as deep as if I couldn't see a blown up part or something toasted, I wouldn't really know what to do. So I didn't take it apart to that extent. So I have a feeling that when I took it to the several different locations that did guitar amp repair, one of those places, somebody in the process of diagnosing it may have misplaced it or forgot to put it back on. And I'm thinking that without that mica insulator, that this can would have, I think this, the collector is the outside of this transistor, would have been touching this chassis ground, making a short. And I think that could have been what caused that fuse to blow in the back of the amp. But anyway, yeah, I tested these. I did some research online, and I got results from the testing of these that led me to believe that they were still in working order, and both had similar testing results. So I acquired another mica insulator, kind of like a gasket, and put in heatsink compound to sort of glue these materials all together, make good strong contacts so that these things could be adequately cooled by the mounting of their bodies to this big metal chassis. Then, once I had the power transistors remounted and both having their insulators in place, I had the jumper wire fixed, and I put in a new fuse, and I turned this unit on, and I heard the sound of the speaker kind of making a little noise, and it had this faint, very light hiss. And the indicator bulb, I didn't have that yet, so that wasn't lit, but it sounded like the unit was on. And I turned the reverb control up and tapped the top, and it, sure enough, it gave the sound of the springs rattling around. Very excited. Then I plugged a guitar into the inputs and was not getting any sound. And I was like, okay, now what? So I started thinking about it, and using the schematic that I had found online for this particular model, I thought about the fact that if I'm hearing the springs and the reverb rattle, that means the output stage, the power transistors, that must be working, and the reverb section, or what's powering that reverb and amplifying that to get to those, that must be working. But if my input that I'm plugging in isn't getting to the output, maybe something's going on in this input section. So with the schematic here, it gives voltages at different points in the circuit for you to be able to measure to see if things are working as they should. And I went through, and it was getting some strange readings up of these first couple transistors. Okay, so here's the input jacks, and they go up to here, go through a capacitor, and then we have a transistor here and a transistor here. Now this one looks different because I replaced this transistor. Now a lot of these transistors look the same and have the same number. I believe they're 4002s, and they're throughout the circuit board. But there are some ones that are a little bit larger, like this one. And since this capacitor is the first transistor that the input signal hits, I was getting strange readings around it, and I decided to remove the original transistor, and in place of it I put a 2N3904 NPN silicon transistor. And when I replaced that, I plugged in the guitar to the input, turned it back on, and voila, I had the signal going through the circuit to the output stage. It went through the reverb, tremolo worked, and everything was solid. Very exciting. And I felt tremendous when that happened. Knowing that when I had the issue originally, I took it to other people who they were being paid for their work doing guitar amp repair, that there wasn't the ability for any one of those to solve the issue, which was just the first transistor being faulty, which there's not that many transistors in here. I don't know the total off the top of my head, but with a schematic on hand, you can go through and get measurements and get the voltages and figure out if any of them have odd voltages around them. And yeah, I believe when I was taking it to these places, I explained, as much as possible too what had happened, and it seemed like you could have likely interpreted that maybe something happened on the front end of the circuit, like the first couple transistors. The last repair person I took it to gave me the idea that it could have been any one of these transistors in here, and that finding it was going to be a great deal of work, and then finding a replacement for it would have been even harder. And kind of gave me this impression like the transistors were just so specific, and the demand for their specificness in the circuit was like critical. It just seemed like, well, how am I going to find a replacement transistor that was from a guitar amp in the late 60s? So I just, I gave up on it. But at this point in my life, with what I've gained in the last 5 or 6 years, I've come to a conclusion where, I just thought there's no way it was going to be that hard to find a equivalent of any sort of part that would have been in this circuit. So yeah, I gave it a shot and got it running. So ultimately, the repairs that I made were a replacement mica insulator on one of the power transistors, a new fuse, a jumper wire, that input transistor, the 2N3904 NPN, and the lamp was easy enough. I had to order those. Oh yeah, and then the ground wire here on the reverb tank. soldered that. Real quick, here's the parts that were pulled out of the unit. Here's the blown fuse that was in the fuse holder. Here's the jumper wire that fell out. Here's the burned out lamp, GE. And then here's the transistor that was removed, FSE 4002. Alright, so I've plugged into the high input. Let's power it up. Alright, so do I have a pick somewhere? There we go. Alright, so volume is at, turn the volume down. But reverb, all the way down, nothing. 9 o'clock. About 11 o'clock. Scary. Alright, turn that down. Let's get the volume up. Let's go up to noon. And I'm sure my phone's probably going to distort on that. Let me take bass up to noon, treble up to noon, tremolo's all the way off, volume. Let's go to 9 o'clock. Let's just turn treble down.